Welcome back to another video, guys. In the last episode we got the engine bay painted and it turned out freaking amazing. But now that that's done, we're on the home stretch. There's just a bunch of little things left to do before we can drive the car. I've got 2 weeks so that I can get it done and make it to an event that I want to go to. So the first thing I'm going to do is get the ECU back in, wire up the engine, and get everything on the front end put back together. So once I get all that done, I'll meet back up with you guys and we'll take it from there. So as you can see, I got the majority of the front end put back together. This thing's really coming along nice. So we got all the fundamentals and everything that we're going to need for a test drive. I'm not going to put headlights or a bumper or anything like that on it until after the test drive. But now that we're at this point, there's just a few things left. The brake system, power steering, and then coolant. So the first thing I'm going to focus on is coolant. So I've got this Mishimoto radiator. It's a dual pass. I believe it's set up for like a 2JZ GTE, like a Supra, which is why it's got the in and the out on the same side, whereas the IS300 has the in and the out on opposite sides. But to handle that, we're just going to run a 90 degree here, an aluminum pipe over, and then another 90 into the radiator. But if you guys remember way back when I did the tube front, I actually tucked the radiator underneath this support here that I built, which means I had to delete the cap. Now that's all fine and dandy because I planned on running an expansion tank anyways to try to eliminate any possibility of air getting trapped in the system. It's just a better overall setup. So the cap is actually going to be over here now. This will be the expansion tank. That's an overflow in case the system gets too hot and has to overflow. It'll go into there. But now I have a gaping hole in the radiator where I cut the fill neck off, so that needs to be capped. And then I have a 10AN aluminum bung that's going to get welded on here to go to the expansion. Now it would be more ideal for it to be on the top of the radiator here to let air out, but since I have it tucked, that's not an option, so I'm going to put it as high as I possibly can, and that should allow all the air to get out. The other thing I need to do is weld on this 1/8 inch NPT bung for my temp sensor. Now I actually bought and planned on running one of these things that you just splice into your coolant hoses. And then it's got a 1/8 inch NPT bung on it. But I figured, I have the ability to weld it. Might as well make it a little nicer, a little more professional, and just weld a bung on here. And not have to have this thing in the middle of one of my hoses. Just an extra, extra clamps. I think I'll be way happier with that at the end of the day. And then last but not least, I need to build a fan shroud for my Volvo fan. If you guys have never heard of it before, it's really big in off-road vehicles, the Ford Taurus electric fans. Because you can get them at a junkyard for like 20 bucks and they pull quite a bit of air. I think it's close to 4,000 CFM on high. They are high and low. So definitely best bang for buck as far as electric fans go. You could spend 200 bucks on a SPAL, like a small SPAL fan that doesn't even pull as much air as this. So I know some FD teams like Papadakis, he actually runs, I believe, a Taurus fan, maybe it's a Volvo fan. They're basically the same thing. They've always ran that, never had problems with it. And this is the same fan that I ran on my M50 when I had that in the car, because one of the first things I did was delete the stupid viscous fan. But I'm definitely going to build a shroud for it. You can go the route, and this is what I did last time, where you just basically zip tie the fan with the through zip tie things that go through the radiator and cinch it to the backside. But then the fan is only pulling air from the fan area and not the entire radiator. And it's also got, all this space here that it can pull air from instead of through the radiator. So a shroud is definitely important for maximum cooling. And I'm going to build the shroud about at least this far off of the radiator to make up for the motor sticking out the back. And then I'm going to put weather seal all around it so that it has a nice tight seal and will only draw air through the radiator. Hopefully that'll keep the car pretty cool. Down the road I may upgrade to an even higher CFM fan, but we'll just see how this thing does. So yeah, time to start drilling holes in this brand new radiator and welding some stuff onto it. So I got my bungs welded on, I got my hole capped off. So now we're gonna start on the fan shroud. So we're gonna take some measurements for that. And then I'm gonna add 1.25 inches to each side. That way the shroud will stand up off of the radiator enough to allow for the depth of the fan so that the fan's not rubbing. I'm gonna use some thin 18 gauge aluminum, not really thick enough to support the weight of the fan. It would probably bounce around a lot in there. So what I'm gonna do is when I put rib nuts on the shroud for the fan, I'll put rubber spacers behind those rib nuts between the shroud and the radiator so that it can't move in. But I'll show you guys once I get that all cut out. Okay, so I've got the corners cut out on my fan shroud and lines marked. So these, this section of the shroud is gonna bend. So I've got it mocked up here on the bench. I'm just gonna take a hammer and fold it over. Got a 2x4 clamped across it to try to give myself a nice straight bend. Probably start it off by hand and then we'll use a hammer to finish her off. Okay, so we'll do that for the remaining 3 sides. All right, so we got the fan shroud all bent up. Fits pretty good. So now what I'm gonna do is make some little L brackets out of just some thin aluminum plate, and we'll weld them onto the shroud, and then they will bolt onto the actual radiator. So I'm gonna do 4 of those. And then once those are on, we can put some weather seal all the way around it and install the shroud. Then I need to cut out the hole for the fan, put some rib nuts on the shroud, and then we can install the fan. So I got my mounting tabs bent and welded onto the shroud, and I got some rib nuts mounted in the radiator. But I need to get some M5 hardware for that. I don't have any. So in the meantime, I'm gonna start on the next fab project, which is the power steering reservoir. So the factory power steering pump has the reservoir mounted on top of it. It sits right here. But when you run a front-facing intake manifold, there's no room for it. So I've got this fitting from Drift Motion that just bolts on there and has an O-ring and turns it into AN. So then we can run an AN line to a remote reservoir, but we still need a remote reservoir. So my solution to that is to modify the factory reservoir that came off of the pump to make it work. So this will get remotely mounted, and then you can see here, this is where it used to go to the pump. There was just an O-ring on there and then it bolted in. So this would be the feed to the pump, and then this would be the return from the rack. So what I'm gonna do is I'm gonna cut off this and then weld on an AN fitting here. So then I can have an AN line from here to here, and then I'll have a line from the rack back to here, and I'm just gonna use a hose clamp on this, but it will be AN on the other side. This is a low pressure side, so the hose clamp will work just fine. But I think one challenge of this is going to be how dirty it is. As you can see, it's extremely dirty and full of oil, so welding it might be tricky, but all we can do is give it a try. All right, quick update for you guys. Michael came over and we've been knocking a bunch of stuff out on this thing. We're trying to get it running and driving today. Don't know if that's going to happen or not, but that's the goal. So the fan shroud, we got it cut out. And we got rib nuts on it, so we can bolt that on. But first I need to put weather seal around it, and then we'll put some weather seal on the radiator and we can attach this. Honestly, I don't think this is gonna move. Well, I was worried that this would be too flimsy and the fan would kind of slap around if I didn't. So I got some rubber things that I could put on the backside, but I don't need them. Okay, so we got the fan and shroud mounted. I had to redo the way the radiator was mounted in here because it was too far forward and the fan was basically touching the crank pulley. But now you can see we got plenty of room down there. So, and just a little update for you guys on everything else we've gotten done. As you can see, we got the coolant hoses ran. Due to this radiator having the inlet on this side and the engine having the outlet over here, we had to use this aluminum pipe. It does have a bead on each end for a good seal. You can get this on Amazon for like, what was it, 20 bucks or something like that. Then we've got a couple of rubber 90s. I really hate the way these hose clamps look, so at some point I'm going to find something better for those, but they'll work for now, obviously. We got the air filter on, all that's attached. The intercooler piping's back on with hose clamps. The throttle body we made a gasket for out of Felpro gasket material, again from Amazon. Pretty cheap stuff. You can get a big roll of it and then you just cut it out to the shape you need. So the fan is wired up now. We've got our power steering reservoir. So we've got our AN line that runs from there to the drift motion fitting here to feed the pump, and then the pump has a AN outlet. And then the pump has an AN outlet right here that goes down right into the steering column right there. And then we have our compression fitting on the factory hard line that then goes to an AN line to return to the reservoir right here. We also have the AN line for the coolant system that goes over to the expansion tank, and then the overflow's all hooked up. And we got our TurboSmart boost controller just kind of chilling right here for now. That way we can actually control the boost. I believe the spring in the wastegate is like a 10-pound spring, so that would be the limit if we didn't have a boost controller. But with that manual boost controller, we should be able to turn it up way past that, and we should be able to get to our 14 PSI goal. And what I did is I have there's a vacuum line going from the intake to the boost controller, and then from there it goes to this factory hard line that's on the 2JZ GE, and then it comes out the other side and then goes down into the wastegate right there. We also have our heater core bypass. This is just some generic heater hose that I got from Napa. It runs from here into the top of the head. There's a lot of debate on whether or not you need that hose. Some people say to just cap it on top of the head and then plug it, on the block. You don't need it. But other people say that you should have that recirculation so the water flows through the head the way it was meant to from the factory. I don't necessarily know which one's correct, but I'm going with this one because it seems like the safer route. It's better to have water flowing through there than none at all. So yeah, that's done. We also got our eBay chassis mount shifter installed and connected to the transmission, so that's exciting. The shift selector rod had to be shortened because the transmission is pushed back from the factory, and I'm not really crazy about where neutral ended up. It's kind of far back. It's not right in the middle like it should be. But it goes in all the gears, so it shouldn't really be a problem. It'll work. If I feel like fixing it later, I can. I'll actually have to make the rod a little bit longer for that to happen. So here's the selector rod. So as you can see, it was cut in the middle and then shortened and re-welded. So next on the list is going to be the drive shaft. Now I'm going to do something a little bit ghetto, but I think it's going to work fine, and if not, the worst that happens is I have to buy a drive shaft. But I'm actually going to cut and shorten my drive shaft and re-weld it back together, and I'll show that to you guys. Around here in Iowa, we have a lot of people that do dirt track racing, and I know some people that have cut and shortened their own drive shafts. They do it all the time on dirt tracks. The biggest thing is when it comes to the drive shaft, there's a lot of different options, but none of them are really ideal for what I wanted. Most people would say to just get a custom one-piece drive shaft with regular U-joints on both sides. You can get one of those for like 300 bucks. They're super strong. The problem with that is that you then have to buy an adapter to go to the BMW transmission because it uses a 3-bolt non-U-joint, and that adapter is like 100 bucks, and then that also eliminates the rubber flex disc on the drive shaft, which, if you're not aware of it, a lot of drifters recommend either having a clutch delay valve or the flex disc just to absorb shock to your drivetrain so that you're not breaking diffs and gearboxes and axles all the time. Now, obviously, it's much easier to just bolt on the rubber flex disc. You just bolt it on. You don't have to install a clutch delay valve, which, you know, you have to run clutch lines to, you have to buy the valve and all that. So I want to maintain that rubber flex disc. Now, you could still bolt on the rubber flex disc and then bolt on the $100 adapter to the 4-bolt U-joint and then, you know, get a custom drive shaft. But then you're still looking at a minimum of about $400 for a drive shaft. So that's probably what I'll do in the future when I need a better drive shaft, but for now I think the stock one will work. Like I said, the worst thing that happens is it breaks and we have to buy a new one. So here's the rubber flex disc that I was talking about. This attaches straight to the transmission. So the drive shaft has 3 bolts, and then offset the transmission has 3 bolts. So this is just the front half of the drive shaft. It's the part that needs shortened. The rear is going to stay the same. Because it is a 2-piece drive shaft that's supported by a carrier bearing in the center. Now, my car being the earlier E36, it had the M50 and the Get Rag transmission. That transmission used a smaller output shaft on the transmission. So my original front half didn't work, but BMW makes basically all of their spline sizes the same, and they've only made like 2 different sizes of output shafts, so the smaller one and the bigger one. So you can see this actually came off an E90. The E46 has the splines on the opposite side, so like this part would be the male and the rear half would be the female. So you can't use the drive shaft off an E46, but the E90 went back to the way the E36 was, and it does work. So this will slip right onto the rear half of the E36, and then I'll have the correct size of the front shaft. Now, just like my factory shaft being too long, this one is too long as well, so I need to cut it and shorten it. And what I'm going to do is I'm going to cut it, shorten it, weld it back together, but then I'm going to take this 3-inch exhaust coupler and I'm going to slip that over the weld and then weld this all the way around. Just for a little bit of extra strength so that you're not relying 100% on just the one weld. I think that'll be plenty strong. It's going to be hard to make it perfectly balanced, but I don't know how crucial that's going to be on a race car. I think there might be a little bit of vibration from it at certain speeds, but I think it'll be okay. And if not, we'll get a custom one later on. But at least this will work for a test drive, and it's going to cost me basically nothing. So the nice thing about this drive shaft design is since this slips onto a shaft, you have a little bit of wiggle room. It doesn't have to be a perfect, precise length. But I've measured that I need to remove 2 3/4 out of this. And that'll give me a little bit of slip room so that I can put it on, get it on, and then, you know, set it in place. So I'm going to start cutting this. I'm going to try to cut it perfectly square with a chop saw. That's going to be a little bit difficult, but I'll probably cut it a little long and then grind it down to where it needs to be so then I can get it nice and straight. Okay, so we got her all cleaned up and ready to weld. Now the important part with the drive shaft is going to be making sure it's perfectly straight. So to achieve that, you can just put it in a piece of angle iron like this, and then you know that it's perfectly straight in there as long as there's no, you know, bumps or divots in anything. So now we're gonna tack this up real quick and then we can weld it out. Okay, so we got the drive shaft done, just need some paint on it. Hopefully it's not too wobbly. And Michael's over here working on the brakes. So we have the Chase Bays brake booster delete plate, but then we just have a universal Wilwood master cylinder with dual output. Because the Formula Drift rules require that you have individual outputs for your front and rear brakes. In case one goes, you should technically still have pressure to the other. But the Chase Bays kit, when I ordered this, they only had a single output reservoir, which is illegal in FD rules. Now they're making a dual output reservoir, which probably would fit a lot better than this one. But they didn't have it at the time I ordered this, so we don't have that. But basically what I did is, if you can see the factory lines down there, I just used adapters to go to AN. The two front lines are teed right there, teed together, and then they run into the output for the front. And then the rear is going into the bias valve and then goes to the output of the rear there. The only other issue with the Wilwood Master is that the push rod is too short, unfortunately. So we're gonna have to extend this. I'm just gonna cut it, weld some extra on there, and then that should be long enough for that to work. And we should have brakes, we'll just have to bleed them. Okay, so we got basically everything done on the list other than getting seats and dash and everything back in. So now we're gonna start filling some fluids. Oh shit. That hose clamp is in the way, we can't get this lid open. So we're gonna run just water in this car since it's purely a race car. Water actually cools better, it's more efficient than coolant is, but we wanna make sure to use some water wetter or some type of additive for corrosive protection, because otherwise your shit will rust inside. So yeah, we're gonna get this filled and get check all the other fluids and fire her up. Okay, so we finally got the brakes and the clutch bled, and we also got the seats back in as well as the dash. Car's all cleaned out. It's filthy right now, but you know, we'll worry about that later. So next, I want to start the car and then make sure that it goes into all the gears and that the clutch works and disengages fully. So we'll do that with it on the jack stand so we can see if the wheels roll in all the gears. Then after that, we can finally take this thing off the jack stands. What was that? What is that? It's cool, right?
Nope, oil.
Oil? Jesus Christ! From where?
That's a lot of oil.
Well, that's not good. I think it's coming from one of the oil cooler lines. Seems to be dripping from right there. So we replaced the lines on the oil sandwich plate because those were leaking, and now it's not leaking anymore. So we'll try this again. Yeah, we need to fix the idle because it's really annoying trying to rev it up and keep it idling while trying to with the gears. Okay, so no leaks. We got the car to idle. We know the wheels spin. So finally, after a year and a half of being on jack stands, this thing's coming down. I almost forgot how low this thing is. I'm so used to it being a monster truck. Perfect. Alright, let's see how this clutch is. Driver. I might have to adjust fuel pressure. Because it seems like it's getting a little lean as I rev it up, so I might have to just increase the fuel pressure a bunch, the base. We'll see. We'll have to mess around with it for sure. Yeah, it moves. Now that we smoked out the whole shop. But wow, look, we got this whole open spot now. And the car's over here. Okay, so the car officially runs and drives. I'm super excited about that, but there's a couple issues. The main one being that it doesn't idle smoothly and it won't rev smoothly. If you try to give it a lot of throttle, it breaks up and just like falls flat on its face. So that's definitely concerning, especially when I have 4 days until I'm supposed to be leaving to go to a drift event 4 hours away. Obviously, if the car won't rev up, we're not going to be able to go to the drift event. It wouldn't make any sense. But there's a few different problems that it could be, and we're going to start with simple things and rule those out first. So the first thing I'm thinking is that the spark plugs are fouled. When we first started the car, it seemed like it idled pretty smooth, but it did create a lot of black smoke just from leftover oil in the pistons that I had put in there during assembly so that nothing would rust. So I'm thinking that may have fouled the spark plugs. We can easily tell if we pull them out. If they're all black, we can clean them up and see if that makes a difference. The other possibility is I've heard that this VVTi ECU can take quite a while to relearn the fuel trims after being reset, so if battery gets disconnected. So it could just be that it's still trying to relearn all the fuel trims, and maybe driving will just fix it. But I definitely want to check the spark plugs first. Okay, so we got the spark plugs out, and as you can tell, they're all pretty black and sooty, pretty fouled out. Now that's definitely not uncommon for 2Js with the stock ECU like this. They're definitely going to run rich, which is going to make your plug a little darker than normal. So ideally your plug should be kind of a medium gray. If it's ashy, then it's running lean. But we're going to go ahead and clean these up with some carb cleaner and a soft wire brush, and we'll throw them back in and we'll see if that makes any difference. Okay, got them all cleaned up, nice and shiny now. So now we can put them back in. Okay, so the spark plugs are back in. I'm about to start it up, and after I start it up, assuming it's still not running right, there's a couple things I want to do while it's running. The first is going to be playing with the fuel pressure up or down, see if that makes a difference. And then if that doesn't do anything, I want to unplug the MAF and see what that does. If neither of those make a difference, I might start unplugging coil packs and seeing if those make any difference. Still has a rough idle. Just a hair over 40 psi of fuel pressure. Well, that was kind of interesting. Okay guys, so after doing a bunch of troubleshooting last night, I couldn't really figure out the issue, but whenever I would unplug the MAF, the car would rev way up and then die all of a sudden. So I think there's definitely a problem with the MAF, and I found I found some instructions on how to test it with a voltmeter, and it seems like it's bad, but I can't get one locally since it's the JDM VVTi MAF, so I'm not going to be able to get one in time for the event this weekend. So we're just going to go ahead and test drive it and see what happens with it the way it is. So you never know what'll happen until you try it. Oh, it's a wrench, goddammit. That's what.
Oh, was that what that was?
Must have been. We got it.
Well, it's a little rough. Yep. Lots of bugs to work out.
Okay, so as you guys could tell, the car was still breaking up really bad when we took it for the test drive. So I'm still pretty sure the MAF is bad after testing it. In the service manual, it says you're supposed to be able to test the voltage pins on the MAF, the ones that are for the mass airflow sensor itself, and that you should have a voltage between 0 and 5, and that when you blow air through it, that voltage should increase, and mine wasn't doing anything when you blew air through it. Now, luckily, I posted up in a Facebook group, a local like drift group, and I found somebody about 30 minutes from me who had one. So I went and picked it up from him. I've got it installed. So now we're gonna start it up and see if it makes any difference. Cross our fingers. Alright guys, so I'm officially going to throw in the towel. There's no way we're going to make it to this event. The car is just not running right. I got the new MAF in, did a voltage test on it, and it seems to be working, but the car still is breaking up really bad and you can't really accelerate at all. So we're not going to make it to the event. We might as well spend the next few weeks before the next event really dialing it in and trying to figure out all these issues. So there's several things we can do, and the main thing that I want to do is add an OBD2 port to this so that we can actually plug in a scanner and pull codes from the ECU and see what problems are happening there. There's ways to do that even though this is a JDM ECU, but we'll get into it on the next video. For now, the car runs, it drives, it's just not quite running right. At the end of the day, we may have to order one of the electronic throttle bodies and throw that in there so that the ECU is happy and can see all of that. We may need a map sensor, even though I'm told we don't. At this point, who knows? It could be all kinds of things causing the car to not run right. But we've definitely made a lot of progress, so at least there's that. So that being said, we'll continue it on the next one. Thank you guys for watching this far, and I hope to see you on the next one.